confidence interval can also be constructed for population variance. To do that, we will use the following formula. So n minus 1, where n is as always the sample size, multiplied by s squared, which is sample variance, and divided by chi-squared alpha 2. So this is one of the critical values that we will need to get, and this time we will use the so-called chi-square distribution, and the values will be obtained from a table. This will be the lower limit, and as for the upper limit, n minus 1 multiplied by sample variance, and this time divided by the critical value of chi-squared for 1 minus alpha over 2, where alpha is as always a significance level. Here you can see a part of the table for the chi-square distribution. So similar to the t-distribution, we will need degrees of freedom, which are calculated as sample size minus 1. And for each value of alpha, we've got, for each value of alpha and degrees of freedom, we've got a specific value of chi-squared, which can be obtained from the table. To construct valid confidence interval for population variance, we need to meet two conditions. Similar to the other conditions for the other confidence intervals, a random sample must be selected from the target population. And similar to the t-distribution case, when we had a confidence interval for a population mean given we are working with a small sample, the population should have a distribution that is approximately normal. And let's have a look at the example. A statistician chooses 27 randomly selected days, and when examining the occupancy records of a particular motel for those days, finds a variance of 7.5 rooms rented. Find the 95% confidence interval for the population variance of the number of rooms rented. So given this description, we can get the following information. The sample size will be 27 randomly selected days. The sample variance is 7.5 rooms rented. And since we are asked to construct a 95% confidence interval, the significance level will be 5% or 0.05. Given the value of alpha of 5%, we can get the two critical values of chi-squared. So for chi-squared, for the level of alpha over 2, so for 2.5%, we get the value of 41.9232, and the critical value for chi-squared at the significance level of 1 minus alpha over 2, so 1 minus 5% divided by 2, we get the critical value of 13.8432. So when we put everything into the formula for the confidence interval, we get the following values. That the lower boundary is 4.65 and the upper boundary is 14.09. Therefore, we can conclude that a statistician can be 95% confident that the population variance of the number of rooms rented lies between 4.65 and 14.09. So the true population variance lies between these two values with 95% confidence.